Dear students, welcome back. In the last couple of classes, I was talking about classification of fuel, synthesis of synthetic petrol, as well cetane and octane number of the particular diesel and petrol engines. And today's class is all about analysis of flue gas. All right, why we supposed to analyze the gas which is coming out from the gas chamber or which is coming out from the automobile exhaust. All right, I will be telling about the process which get involved in the flue gas analysis. So basically the flue gas analysis can be done with the help of Orsett apposite. The picture which is shown in this diagram will tells about the process which get involved in the Orsett flue gas analysis process. So basically when you look at the automobile exhaust, when you analyze the exhaust which is coming from the industrial area or else the combustion of fossil fuels in the automobile engines, like when you analyze the gas which is coming out from the IC engines or diesel engines, it will found to have much amount of sulfur oxides like SO2, CO2 and a little bit of oxygen molecule and considerable amount of carbon monoxide. So by analyzing these automobile exhaust, you can tell us about the chemical reactions. We can tell about the type of chemical reaction which are taking place inside of the engine compartment. So in order to analyze such kind of pollutants, we have to go for the process called Orsett apparatus process, Orsett method, and this is a typical instrument which can be used for the analysis of flue gas. And it will have an horizontal tube, and one end of the tube is connected with one U tube, and it is filled with fused anhydrous calcium chloride, and the other end of the tube is filled with one burette. This is the burette, and the burette is subjected with one funnel. It is filled with liquid water. And what is the purpose of keeping calcium chloride inside of the U tube? So basically when you look at when you analyze the nature of the calcium chloride, it is a kind of dehydrating agent. The flue gas may found to have some amount of water molecule, moisture content may be available on it. Once you get the material inside of once you get the flue gas from the engine compartment, it may not have water molecule, but when you store the flue gas in the container, it will have, there is a possibility for the condensation process. As a result, it will have some moisture content, and the moisture content will be absorbed by passing the flue gas through this calcium chloride, because the calcium chloride is a kind of agent which is able to remove the water from the material. So therefore it will be used as a dehydrating agent. And also it will have three bulbs, bulb A, B and C. So what is the purpose of keeping the three bulbs in the Orsett apparatus? So basically the bulb A is used to absorb the CO2 molecule, and in order to absorb CO2 molecule, we have to fill this bulb with the help of potassium hydroxide. So what should be the concentration of potassium hydroxide? We have to take about 250 grams of potassium hydroxide, and it has to be dissolved in, it seems like a paste, 100 ml of water. That paste has to be filled in this compartment. Chamber A is filled with concentrated KOH, and chamber B is filled with the bulb B is filled with alkaline pyroclal. So for this we have to take about 250 grams of pyroclal material plus 200 grams of KOH and about 500 ml of water we have to take, and we have to dissolve these two elements, like 25 grams pyroclal and 200 grams of KOH has to be dissolved in the water, and such highly concentrated material has to be placed in this B chamber. And for bulb 3 or chamber 3, it is filled with basic cuprous chloride, Cu2Cl2 plus liquid ammonia, and it has to be about 100 grams plus 125 ml of liquid ammonia. So when you mix this liquid ammonia in the water, it becomes ammonium hydroxide, and about 375 ml of water. So this composition has to be filled in this chamber B or bulb B. Now we are going to operate this Orsett apparatus not to analyze the type of pollutant which are available in the exhaust gas. We are going to pass this flue gas through this U tube. Once you pass this gas through this U-tube, it will absorb all the water molecule. Now the water molecule free gas is allowed to pass through chamber A, where will have some opening also. I mean stopper is also available over here, and valves are also available over here. Now we are going to pass this gas through the chamber A initially. Now what happens, it used to absorb, it used to pass through it, through this chamber, and it is connected to this. Now it will go and raise the water level. So initially the water level is maintained till this range. So once you pass the flue gas through this apparatus, it will go and increase the water level in the funnel. Now this has to be calibrated likewise. Then the water molecule free flue gas is allowed to pass through the bulb A. Now it used to, the calcium, I mean the potassium hydroxide will try to absorb all the CO2 molecule. So all the CO2 molecule which is available in the flue gas will be absorbed by this column A, and with respect to the volume of carbon dioxide molecule, the change will take place in the burette. The water level will be changing, keep on based on the quantum of carbon dioxide is available in the flue gas material. Basically before this, it will be circulated here and there to absorb all the CO2 molecule. And once we have to make sure that once all the CO2 is absorbed by this alkaline material, now the CO2 free gas is allowed to pass through the chamber B, where we are having alkaline pyrocolol, high concentrated pyrocolol. So now it will absorb all the O2 molecule. So this is mainly for CO2 absorption, this is mainly for O2 absorption. Now all the oxygen molecule will be absorbed in this chamber B. Now the CO2 molecule and oxygen molecule free gas is allowed to pass through this chamber, the third chamber, C chamber, where it used to absorb all the CO molecule, carbon monoxide molecule. So depending upon the volume of oxygen, carbon dioxide and carbon monoxide molecule, there will be change in the burette readings. So based on the burette reading, we are going to calculate the or correlate the quantum of the pollutants which is available from the, which is coming out from the automobile exhaust. So what are the information we can infer from this analysis? So when you look at the flue gas material, if the flue gas found to have more amount of CO molecule, if more CO is present in it, we can claim that it indicates that insufficient oxygen supply, insufficient O2 supply for the combustion process. So therefore we have to supply sufficient amount of oxygen to the combustion process. So when you take IC engine, the air fuel ratio must be in the range of 1:17. If the ratio is getting reduced, it used to emit much amount of carbon monoxide, because carbon monoxide is a highly toxic element. It should not be released in the atmosphere in the maximum range. So therefore the percentage of CO indicates that quantum of oxygen supply as well as the completion of the combustion process. The second one, if more amount of oxygen is coming out from the automobile exhaust, so we can claim that, or we can say that we are supplying excess amount of oxygen molecule for the combustion process. So therefore there won't be much amount of carbon monoxide. If CO is max, both are interrelated, both the quantum of O2 and quantum of CO is both are interrelated. If you supply much amount of oxygen molecule, the exhaust found to have more oxygen molecule, and it will the CO level will be very less. If we supply less amount of oxygen, then the CO level will be maximum, because there will be incomplete combustion. As a result, it will release more amount of carbon monoxide. And the third one, carbon dioxide. If more amount of carbon dioxide is coming from the automobile exhaust, you can claim that the given hydrocarbon fuel found to have maximum amount of carbon content. The calorific value much more higher. And the SO2 tells about the, it's a warming signal. So if SO2 found much amount in the automobile exhaust, we have to reduce, we have to replace the sulfur from the corresponding fuel. Maybe for example, if you take coal, Normally coal found to have certain coal found to have maximum sulfur content, so we have to remove the sulfur, and for this we can go for various treatment process. In fact, it can be done with the help of biological process also. There are certain type of sulfur eating bacteria is also available. So when you introduce the sulfur eating bacteria on the coal component, it will eat all the sulfur content. So the sulfur free coal can be used for converting either synthetic petrol, or it can be used as such in the corresponding power plants or other purposes. So this is all about the information can be obtained from the analysis of flue gas. So I just conclude flue gas analysis is much more helpful to tell us about the quality of automobile exhaust. Depending upon the quantum of element present in it, we can tell about the quality of fuels. If more amount of sulfur is available on it, it gives the warning signal. So we have to remove the sulfur, because sulfur is one of the toxic pollutant. If you introduce such pollutant in the atmosphere, it will create acid rain process, acid rain phenomena. So it has to be replaced completely before the combustion process gets started. In the case of fuel, in the case of coal, we have to remove the sulfur with the help of desulfurization process, or we can go for sulfur eating bacteria. And secondly, if carbon dioxide is maximum, so we can claim that we are supplying sufficient amount of oxygen to the combustion process. And third one, oxygen molecule. If we are getting more amount of oxygen from the automobile exhaust, can claim that we are 100% sure that the combustion process is 100% complete. And the last one, CO, it indicates that incomplete combustion process. If you supply less amount of oxygen molecule to the engine compartment, it will increase the CO percentage. So the CO is very dangerous toxic pollutant. We are not supposed to release such kind of toxic pollutant in the atmosphere. And also we can claim, it also tells about the unburned hydrocarbon which is available in the automobile exhaust. So that has to be monitored regularly. If unburned hydrocarbon is introduced in the atmosphere conditions, it will create number of health issues to all the living organisms. So therefore, the analysis of flue gas is very, very important. So that is the reason why we used to have smoke test periodically for our vehicles. So that's all about the information pertaining to the analysis of flue gas. Thank you very much.